Okay, everyone. So I have an announcement to make. So I realized that some of you weren't doing well in the first two exams, and in order to encourage you to study really hard for the remaining of the semester and to improve your grades, I'm going to do this. So if in the next exam you get a really high grade, at least 30 points more than your previous exams, imagine you have like 30 in exam 1, 20 in exam 2, and in the next exam you get 70 or like 80 or 90, But as the sake of the example, what I'll do is that I cross out your lowest grade and substitute that with your high grade so that I can improve your grade. So basically this only helps you to increase your grade. And if you have like, 100 in your first exam, or it doesn't hurt your grade, I only do this if your other two exams are low or you have a really low grade, and then you get a really high grade in the third exam. Basically, I omit your low grade and substitute that with your high grade. So it means that still you can get really high grade in this course. And I hope this encourages you to study really hard for the third exam, fourth exam, and then final exam, and the quizzes, and so on and so forth. Is it clear what I'm going to do?
So basically, we have to get 30% higher on the next one to have that happen?
So it should be considerably higher, not exactly 30%, but if you get for instance, 30, 20, and then here you get 35, these grades are fairly similar, at least 20 points higher, So if I see, basically I want to see that, okay, you are really encouraged and your third exam, wow, is much higher, if that makes sense. So it should be at least 20 points higher. So is there any objection about this? That anyone that doesn't like this? Yeah. I'm trying to encourage you to study hard for the rest of semester and still get a really high grade. Okay. So if there is no question about this, yes. Yep.
Are you following the exam schedule? Next week it says that we're supposed to have a quiz and an exam.
Yes.
Is that the case with this one?
Yes, I'm following Professor Stelz's schedule, yeah. So anything that you have in your tentative schedule, I'm just following that. So I'm going to post the quiz, I try to post it sooner on Wednesday, so you have more time to work on it. But in the schedule, it says Friday, that I'll post the quiz on Friday, and then you will turn it in back to me, I think on Wednesday, but it's exactly the tentative schedule. So I follow that.
And then also do we use syllabus, right?
Yes, yeah. Everything is the same. Any changes to the course, I'll tell you in the class. But other than that, everything else, office hours, the zip grade, quizzes, exams, number of quizzes, everything. But the changes, I'll tell you. Okay, so if there is no question about this, I just go ahead and... Okay. So, any question about any materials that we learned so far? Okay, so I continue with chapter 6. And let me just get rid of this. Okay, so we're on the section 7 of chapter 6, which is mass percent composition from a chemical formula. So what we did last week, I told you that we can be given mass percent composition by experimental values. For instance, we can be given that mass percent of sodium in sodium chloride is 39%. And this is something that is given to you in the problem. And based on that, you can do other calculations, find gram or mole of sodium or chloride, and so on and so forth. So now we want to find mass percent composition from a chemical formula. And I solved the problem last week. If you remember, it was about the sodium chloride that I showed you how you can calculate that, just like how we were doing so far, But your book gives a formula to calculate mass percent composition from a chemical formula as well. And that is basically, as the following. Mass percent of element X equals mass of element X in 1 mole of compound divided by mass of 1 mole of compound multiplied by 100. And when you do that, your answer would be percent. That means if you want to calculate mass percent of a specific element, imagine you have like sodium chloride and you want to calculate mass percent of sodium. You calculate mass of sodium in 1 mole of compound divided by mass of 1 mole of compound multiplied by 100%. And this is similar to what we did last week. So because I really want to go through this chapter, I don't write down the problem that I solved last week. But if you remember, we wanted to calculate mass percent of sodium in sodium chloride. And that means that if you want to calculate mass percent of sodium in sodium chloride, it means that if you have 100 grams of sodium chloride, how many grams sodium you have. So this is something that we were solving, so far, that we said how many grams of sodium equals 100 grams of sodium chloride. And you write a conversion factor that relates gram of sodium chloride to moles of sodium chloride. And then you convert mole of sodium chloride to mole of sodium by chemical formula. In this case, is 1:1. Multiply of mole of sodium to gram of sodium. And we did this math and we find that 39 grams of sodium is present in 100 grams of sodium chloride. It means its mass composition is 39%. So this is something, that we went through last session. Any question about this? Is it clear? So basically, when you are given a gram of a compound and you want to convert it to the gram of a constituent element, first you use molar mass to convert the gram of the your compound to moles. You use chemical formula to convert mole of the compound to mole of element, and then again molar mass to convert mole to gram, right? But what you can do here is that to just use this formula. So basically, the question is that calculate mass percent of sodium in sodium chloride from chemical formula. So one way is just what I told you, that you write your conversion factors, gram to mole, mole to mole, mole to gram. The other way is that to just substitute in this formula, which is mass percent of sodium equals. So here you should remember, you put in the numerator mass of sodium in 1 mole of compound. So you see that we have like sodium chloride NaCl. So 1 mole of NaCl has 1 mole of Na. And then you go to the back of your book for sodium. Here, 1 mole of sodium has 22.99 grams of sodium. So you put that in the numerator, and then mass of 1 mole of NaCl, which you know how to calculate, right? You go to the back of your book, you have like Na 22.99, and then Cl 35.45, and then basically you say molar mass of NaCl equals 22.99 plus 35.45, which would be 58.44 gram per mole. It means that 1 mole of NaCl has 58.44 gram of NaCl multiplied by 100%, which would be 39%. So when I want you to calculate mass percent from chemical formula, one way is to just remember this formula. One way is just remember this formula, that mass percent equals mass percent of the specific element that you want, basically mass of that element in 1 mole of compound divided by mass of 1 mole of compound multiplied by 100%. The other way is to just, write your conversion factors that we did previously. And then if you look at these two closely, so this is kind of what we were doing last week, that I just showed you, would be 39. The other one is just use the formula, which I just did. And as you can see, these two are basically the same thing. Here is like 100 multiplied by 22.99 divided by 58.44. The other one is like 22.99 multiplied by 100 divided by 58.44. So basically these two ways are like the same. But whichever is more convenient for you, whether you can use the formula or just like write your conversion factors. Any question about this? And the important thing here is to, if you write your conversion factors, when you convert mole of element to mole of compound, you have a specific conversion factor for that. But here, it's kind of like inherent in this statement. When you have mass of element X in 1 mole of compound, you should remember if you have like 2 moles of the element, you should kind of consider that here. But when you write your conversion factors, you had an explicit fraction for that. Okay, if there is no question on this, I'm going to, I'm going to go to next section, which is calculating empirical formulas for compounds. So what we did so far is that from chemical formula, we calculated the mass percent composition. Now we want to see if we can do the opposite. If we have mass percent composition, can we find the chemical formula? So basically, you have chemical formula, and from that we find mass percent composition. Can we do the opposite? And this section in general is really good, for like conceptual questions, and probably, I'm telling you, I'm going to give you questions of this section and then ask you about these things, because it has like more concepts to it, and I can ask you about those. So the answer is that, we have two types of chemical formulas. And this is chemical formula. Okay. We have empirical formula and we have molecular formula. Does anyone know what is the difference between these two? So basically, oh yes.
So like, molecular formula is like how much it actually is like for H2O or something like that.
Uh-huh.
But if you had like 2H2O, the empirical formula of that would be H2O.
Yes. So basically, empirical formula gives you the simplest. It gives you the fraction of the atoms, but the simplest. For instance, if you have imagine your compound is H2O2, right? This is the molecular formula, but the empirical formula is HO. Basically, empirical formula is the smallest whole number ratio of the atoms in a molecule. Is it clear? So for instance, if you have C2H6, this is molecular formula because you still can simplify these numbers. The ratio can be lower, it can be like CH3. So I'm going to write this is empirical formula. This is molecular formula. This is empirical. This is molecular. So if you see a formula and you can still simplify that formula, you can divide both number by a whole other number. For instance, here you can divide both sides by 2. The same thing here. That is molecular formula. Empirical formula, in that, the ratio between the atoms cannot be more simplified. In other words, let me just write the definition so it would be more clear. Basically, empirical formula gives the smallest whole number ratio of each type of atom in a compound, not the specific number of each type of atom in a molecule. Molecular formula, on the other hand, is always a whole number multiple of the empirical formula. So basically, empirical formula gives you, the ratio of the atoms, and that is, the numbers itself, here, for instance, this is 1, this is 3, is the smallest whole number, and you should remember that it should be like whole number. If you calculate, I'm going to go through an example right now, but if you find like 0.6, that is not a whole number. If you have like 0.5, 2.5, those are not whole number. It should be smallest whole number ratio of each type of atom in a compound. So just remember that, just have like, because one of these examples in your head, like, for instance, if you have like C2H6, can I, ask yourself, can I divide both sides by a whole number still? If you can, that is not empirical formula. The number of atoms in an empirical formula, you cannot simplify those. Is it clear? Okay. And as I said, these ones, kind of like I can give you true or false, or kind of like, the exam would be multiple choice. But say which of these examples are not true, And then I said, here it says empirical formula is not the specific number of each type of atom in a molecule. And I say, it gives, you should say, you should realize whether it's true or false. So as I said, this section, gives me this flexibility to ask you about the concepts, or kind of like give you structures of molecules, and then say which of the following is not an empirical formula. And then I have like, CH3, I have like C half H3, I don't know, kind of like similar to this, or like C2H6, and then ask you which of these are not empirical formula, or which of these are molecular formula, or kind of what is the difference between the two. So kind of like to give you a heads up about this section, about the definitions, and so on and so forth. And then this basically thing that I gave you here, I can kind of like give you charts like molecular formula, mass, percent, composition, okay. And then say, can we, is this true or false? And then that from mass, percent, composition, directly we can find empirical formula. We still need another calculation to find molecular formula. So kind of like, so this, I don't know why it does that. Molecular. So this would be empirical formula. Any question about this? Okay, now we want to now we learned that, okay, from mass, percent, composition, we can find empirical formula. And I'll show you that from empirical formula, we can find molecular formula if we have like molar mass. But let's just learn how to actually calculate that. So calculating an empirical formula from experimental data. Okay, so imagine you have water in laboratory and you want to decompose that to hydrogen and oxygen. And imagine you did this experiment in your lab, and now you have the grams of oxygen and grams of oxygen. And now you want to learn how to write empirical formula based on that. So I'm just gonna write this. Suppose we decompose a sample of water in the laboratory and find that it produces 3 grams of hydrogen and 24 grams of oxygen. Determine an empirical formula from these data. So what you do when you want to find empirical formula and you are given this information? Remember, previously I told you that when you have chemical formula, it gives you information about moles of atoms. If you have like 1 mole of CO2, we have 1 mole of C, 2 moles of carbon. Or like 1 mole of H2O consists of 1 mole of oxygen, 2 moles of hydrogen. So now, when you are given information based on weight, based on gram, you should convert those to mole. So it's kind of reverse of what we were doing previously. So what you do is that you say how many mole of hydrogen equals 3 grams of hydrogen, and then how many mole of oxygen equals 24 grams of oxygen. Any question about this? Okay. So basically, if you learn the materials from previous sessions, these are just like, all the things come together. You just like use whatever you learned before now to solve the problem. So what you do is that you write a conversion factor. Again, in denominator, you have the thing that you are given. In the numerator is the thing that you want to find. The same thing here. Gram of oxygen, mole of oxygen. And do you know how to write these conversion factors? Where do you get these numbers? Anyone? Just shout it. Yes, exactly. You go to your periodic table. In your exam, I'm going to give you periodic table. In your quiz, you have just back of your book or like any other periodic table that you use. Hydrogen is 1.01. Can anyone tell me the molar mass of oxygen?
16.
Exactly. So, and you remember when you write these things, remember 1 mole of hydrogen has 1.01 gram of hydrogen. When you write this, sometimes, people mess up the conversion factor. You just write 1 mole of hydrogen is 1.01. 1 mole of oxygen is 16. And then, when you do that, here would be 3 mole of hydrogen. Here it would be 1.5 mole of oxygen. So the number is 2.9, but your book rounded that. Whether you round here or at the end doesn't make a difference in the solution. So here is H3O 1.5. So is this our final answer? Why? Exactly. This is not a whole number. We still should, make it a whole number. So what we do, as your friend said, we divide both sides by 1.5. And then you get H2O. So when you want to find empirical formula based on grams that are given in your problem, what you do is that you calculate moles of specific elements, and then you write your formula as you have. And then you ask yourself, does it have the criteria that I want? Is it the simplest whole number that it can be? If it's not, you should make it that way. Any question about this procedure or any other thing in general? Yes?
Why do you get 2 and divide 3 by 1.5?
Here?
Never mind, we're good.
Okay. Okay. If it's clear, I'm going to go to the next section, finish that, and then I'm going to write, some examples for you and solve some problems. But I really want to make sure that I finish this chapter today. So, section 6.9 is calculating molecular formulas for compounds. So do you remember what was the difference between empirical formula and molecular formula? Exactly. So with the same rationale, if we have like the empirical formula and we know what is the number that we should multiply that to get molecular formula, we can find molecular formula, right? Imagine that, as we said, if we have like CH3, this was empirical formula. And then if I know that what number I should multiply both sides, both elements, to get molecular formula, we can basically write that, right? So if I know that, okay, I should multiply both sides by 3, for instance, C3H9. That would be my molecular formula. So basically, I need to find this number. And basically, I can write this as this, that molecular formula equals empirical formula multiplied by n. And we know n is 1, 2, 3, and so on. So, can anyone tell me how do you think that we should find n? Provided that we have if we have molecular mass of our final compound. Basically, if I give you molar mass of the final molecular formula and you have your empirical formula. So imagine in this problem, I tell you the molar mass of molecular formula. If you have that, right, and then you have your empirical formula, do you know, can anyone tell me that how I can find this number? So you have like molar mass of your molecular formula, you have like your empirical formula, and now you want to find this n.
Does it have to be divisible by the number that you find in the empirical formula? Like, does it have to be able to simplify back down?
So yes, so basically your n should be like 1, 2, 3 when you find that. But if you, so basically it's not necessarily, but you round that number when you do the calculation. So you have like, so anyone? Yes.
Would you take the molecular mass of the empirical formula and then divide it by the molecular mass for the entire form you're given?
Exactly. So basically the same thing, but just like reverse. If you have like the molar mass of molecular formula, divide that by the molar mass of empirical formula, it would be your n. Exactly. But when you do that calculation, as you mentioned, maybe it won't be like a whole number, but you round it to find your n.
So can you show that in an example?
Yes. We just go through an example. Oops. Okay, no, it's not cooperating. Okay. Just want you to see this. Okay. So let's go through an example. We have naphthalene is a compound containing carbon and hydrogen that is used in mothballs. Its empirical formula is C5H4 and its molar mass is 128.16 gram per mole. What is its molecular formula? So what you do is that first you find the molar mass of C5H4, which is your empirical formula. So do you remember how to do this calculation? Can you tell me to write it? So how do we calculate molar mass? Anyone? Okay, yes. Exactly. When you're all quiet, it makes me so scared. I'm like, you don't know how to do this? You know, but you don't say, right? Okay, so calculating molar mass is like calculating formula mass. So what you do, you go to your periodic table at the back of the book, and then first you say, how many carbon atoms do I have? How many? And then, can you tell me what is the molar mass of carbon? Yes, 12.01. Plus, how many hydrogen atoms? And then, what is molar mass of hydrogen? Okay, yes. And then, after doing it, this would be like 60.1 0.05 or 64 gram per mole. Always write your units. Is this clear? Okay. So now you remember so it was the equation that relates molar mass of your molecular formula and your empirical formula. So basically your molar mass of molecular formula equals molar mass of empirical formula multiplied by n. So basically n is molar mass of your molecular formula divided by empirical formula molar mass. So this number is given. You don't have to worry about molar mass of your molecular formula because it is given in your example. So what you should calculate is molar mass of your empirical formula, which is like finding, molar masses of compounds that we learned, so it's nothing challenging. So what you do, basically just write a fraction. In the numerator, you have like 128.16. And the denominator is like 64.09. And both are gram per mole. So this is dimensionless. Can anyone do this and tell me what the number would be? And then when you calculate this number, you round it to the nearest whole number, which is 2. So now you have your empirical formula, which was C5H4. If you multiply that by 2, you get C10H8. So this is your molecular formula. Any question about this? So basically, just, kind of like, summarize. You are given in this problem the molar mass of your compound. You have your empirical formula. You calculate molar mass of empirical formula, divide the two numbers, and then round the number to find your n, and then multiply that by your empirical formula to find molecular formula. So let's go through another example, if this is clear. So a 3.24 gram sample of titanium reacts with oxygen to form 5.40 gram of the metal oxide. And you're probably going to see something similar to this in your exam. What is the empirical formula of the metal oxide? So you have titanium, and that reacts with oxygen, and gives you basically metal oxide. And you want to find its empirical formula. So you have 3.24 gram of Ti, and you know it says you have 5.40 gram of metal oxide. So can anyone tell me how would I find the gram of oxygen? Exactly. So if I do this, minus 3.24, it would be 2.16. Or you can just like write it, mass of oxygen is mass of oxide minus mass of titanium, which is what I just did right now. 2.16 gram of oxygen. And then from here, you remember, if you want to write your chemical formulas, the number of elements, they're related with mole. You cannot just like write chemical formulas without doing mole calculations. And now you say how many moles of titanium equals 3.24 gram of Ti, how many mole of oxygen equals 2.16 gram of oxygen. And then you write your conversion factors. And then remember, you want to cross these two out, so you write it like this, mole in the numerator, gram in the denominator. The same thing as here, oxygen. And you know that you go to your periodic table and then you find Ti. Can anyone tell me molar mass of Ti? Yes. And 1 mole of Ti, always tell yourself 1 mole of Ti has like 47.88. And what is that number for oxygen? Yes. And then when you do these calculations, you get this number, 0.0677 mole of Ti, and then 0.135 mole of oxygen. And then you write that Ti 35, and then what you do, divide both sides by the smallest number. When you do that, you find Ti1O2. So this is empirical formula of the oxide that problem asked you. Any question about this? So if you know the procedure, the rest would be the same. So I posted in Blackboard, also in my website, and I hope you guys saw the announcement. Since in the class, I cannot go through as many as examples I want, I'm holding extra office hours in the sense, so I still have my own office hours, Monday, Wednesday, Friday, after class, basically 12:30 to 1:30. But that gives you a chance, the extra sessions that I posted, would be both in person. You're welcome to come to my office. If I see so many people show up, I reserve the room. But so far, based on the answers that you've given, I don't think that would be the case. Also, I have like Zoom sessions at the same time, so you can ask me your questions, and any questions that you have, even if you didn't learn anything, so far from these chapters, I'm willing to explain to you. So just, come to me, talk to me, ask me questions, and any questions that you have, I'll help you to, learn everything. But you should be willing to kind of reach out to me and give me the chance that I can explain to you.
I won't be here now.
Uh-huh.
So how will I exactly raise that?
So you can just email me your Scantron.
Okay.
Yeah.
And then for the exam on Friday next week.
Uh, oh. So when would you be back?
I will be back the Saturday of that.
Okay. Can you email me? I'll think of a date or something and then let you know. Just email me.
Yep.
Okay.
Quick question about the very end part. So I understand everything about how you got the gold loss and the gold protection. Why did you divide it on your .06?
So you get the smallest number between those two and divide both sides by the smallest number.
Okay.
And after doing that, you round the number. Yes.
Can I get a grade report?
What's that?
Can I get a grade report, please?
Yes.
Can you do it since Mr. Stuff is
Okay. I should go and check your grade. Can you bring this to my office hour or no?
You can put a pass on it.
I should go check the grade as well. I have it in my laptop.
Okay. And there's no attendance, right?
No. Have fun, Sam.
Alright, sounds good. Thank you.
Okay, so come to my.
What's office hours again?
It's like, you can just stop by my office anytime, but it's 12:30 to 1:30 and it's 001 rental hall.
Okay. Thank you.
Okay.
We don't have class. Yeah, that is now.